Alright, so now let's actually talk about the general term. So the previous little module was kind of leading on to this. So this here is what the general term for the binomial theorem is. So we have that tk plus 1 of the expansion of a plus b to the power of anything, so n, is given to us by this formula here, which is tk plus 1. So this is our term here, and we have tk plus 1 there. And this is nck. So can you see how that's 1 less than that? Yeah, as we had previously. And then a to the power of just that minus that, so it's n minus k. And then finally, b to the power of k, so that number there. So this is really similar to what I was explaining before. The only difference is, instead of having tn, and then that equals to nc n minus 1, which all gets a little bit too complicated with the minuses, is that we're going to make this k and just add 1 there, rather than make this k and then subtract 1 there. Alright, that's the only difference. So why that's important to know that we're adding 1 here instead of subtracting 1 there is that when the question wants you, for example, to find the 8th term, yeah, what's important for you to do is know that this is the same as t7 plus 1, okay? And this 7 here is our k. So k equals to 7. And it's that k that we need, as you can see, to be put into our expansion over there. All right? So remember, general term is, the term is given to us, k plus 1 equals to nck, and a to the power of n minus k, and then b to the power of k down there. So I think that's pretty easy to remember because we've kind of gone through why that is. So let's go through some questions now where I want you to work out how we do write the general term for specific expansions. So starting off with question 8 here, I want you to try writing the general term for tk plus 1 of 2x plus 3 to the power of 10. Okay, so I want you to try writing the general term for that. So remember, general term is always tk plus 1. And it's quite simple because we just have a look here. That's to the index of 10. So this here is 10 as well. So it's just 10ck. And then 2x is our first term. So we have 2x to the power of 10 minus k. Yeah? Our second term is positive 3. So it's just times 3 to the power of k there. And that's it. That's all you need to do for that one there. So it's pretty simple, right? Alright, good. Let's move on here to question 9. So here I want you to try write the general term tk plus 1 for 4x minus 3y to the power of 9. Okay, so have a go first before I show you the answer. So remember, we know it starts off with tk plus 1 and it equals 2. We're going to be starting off with 9ck, right? There. And our first term here is to the power of 9 minus k, easy. And then multiplied by our second term, be careful here, because it's minus 3y, we take the whole negative 3y as our second term, all right? So be careful with the negatives. So multiplied by negative 3y to the power of k down there, easy. So only thing here you have to be wary of is if you see a negative there, you have to think of the second term as a negative rather than just a minus. Now, what about fractions? Let's practice writing the general term of this. And here, note how it specifies in its simplest form, which means we're probably going to have to simplify a little. So let's write the general term first. So tk plus 1 is going to equal to what? So that's 12. Yep, good. It's going to be 12ck. This is our first term. So x squared to the power of 12 minus k. This is our second term, 2 on x to the power of k. Super easy. Now, we just need to find it in its simplest form. Can you see how they're both x? So you know that you're going to be able to put them together somehow, right? So this is why we do need to simplify it. Now, let's simplify first by expanding these brackets. Here we have x squared, and that's the power 12 minus k. So I can multiply these indices together. So I get 24 minus 2k there, right? Whereas here, this is essentially 2 to the power of k, and I've just made that 2 times x to the power of negative 1, the whole thing to the power of k. Yeah? So here you have x power negative 1k, or x power of negative k, whichever way you like to think about it as. And now you can see that this x and this x is a common term, which means that we can add its indices together. So you just have 24 minus 2k, subtracting another k, just gives you 24 minus 3k, multiplied by 2 to the power of k there, and you can just write that in front. So this here is that simplified. So just note to yourself that whenever you do write the general term, and you can see that these two terms here have the same as x or the same as a or something, you know you can simplify it by putting it together there.